forget about that. But fuel economy, yes. If we could have a very simple calculation saying that okay, fuel economy in the sense how much money you spend, or there is an equivalent of how many kilometers per liter you spend, or either you can always map in terms of money. Yes, you will get the very good figure to convince yourself that okay, yes, we can go for the electric vehicle. That is one. But then the initial cost of the electric vehicle is really high compared to the conventional vehicle. But that is because of the cost of the battery and other things. That anyway, these are all the factors. It's still we could not see more electric vehicle in the market. One is the cost. The another one is the infrastructure. That is also very important. We need to have the charging infrastructure to charge the vehicle wherever we like. That is one. The other one is the charging technology. I could see some of the titles of the presentation talks about charging technology and different type of methods, wireless charging especially. But then we have to look all these things in a big picture. For example, if everyone have either one or two electric vehicle, then what happens? What could be the impact of this to the power system network? And the impact of the power system network can be handled by the other experts. But how the manufacturer or how the aggregators or the people who are in between to supply the electricity to the vehicle for charging, those business models yet to be developed in a proper way to handle this, because it's all we never have such a situation that okay, most of the cars are electric vehicles. Then what could be the case? How we can charge? How much load it actually need, and what kind of coordination? So these are all the other factors involved with electric vehicles. So those are all the research topics, that how you can really go about it. So as such, electric vehicle concern, if you look at only electric vehicle as a study, not much things other than developing some kind of ideas, algorithm for drives, because we can't do much over the battery chemistry and all, because it's in a different material level. So new materials only can be developed to accommodate the specific energy, the weight of the battery. All those things will be taken care of if some technology advancement happens in the materials level, the storage technology, that material levels, if something happens, fine. But from electrical point of view, there are other things one should look. If that's why I try to explain you from a very basic methods or tools we use to have this powertrain components. Very basic powertrain components. We'll see how we can move step by step. So one is about these are all the split up of the whole presentation. One is about the introduction. Already I'm talking over the introduction itself. Another one is the components, electrical powertrain components. What are the components we will really look for, and those things. Another one is the design, a simple exercise. I will tell you how to arrive the sizing of the powertrain components in an electric vehicle. Okay, this is what I'm going to discuss in this lecture. Hopefully, it's clear to all of you. If any doubt, if you're there in between, you can ask. You are free to ask, so that I'll also get a feel that the lecture is going on. Okay. Hopefully, the screen is visible to all of you. Is it visible? The slide is visible to you?
Yes, sir, it's visible.
Okay, fine. So anyway, these type of pictures you could have seen many.
Sorry for interruption. It will be good if just maximize the window, sir.
Yes, sir. I did not hear.
Sir, it will be good if you maximize the window.
Maximum?
Because the slide is very maximize the window, sir.
I think this is the full scale, because I have to annotate in the picture.
Okay. Okay, sir.
I
Okay,
mean,
sir. Then we
page
can
in the
proceed,
left
sir.
and right. So it's not the, it's a PDF, but it is inserted inside OneNote. So I will write it here. So,
Okay, sir.
okay. Yeah. So these are all the very simple picture tells you about, okay, how the electric vehicle looks. I don't know how many of you have seen inside of an electric vehicle. So if it is not, yes, this is what the cut through picture of how it looks. So the main portion here you could see there are see battery pack. So this is the main part. Okay. So if you take a cost of the vehicle, almost like 60 to 70% of the cost goes for this battery pack. That is the simple thumb design. We'll tell that 60 to 70% of the cost you have to spend for the battery, and even they are trying to get down the price of the battery. This is about lithium ion battery. So this ion could be anything, but lithium is the very basic material. So 1 kilowatt hour battery, the whole everybody try to do research, and then they try to bring down less than 100 US dollar. This is what the simple fact you can keep it in your mind. If you want to buy a 1 kilowatt hour, that is 1 unit battery, you can play around the voltage and current rating. That is up to you, like what value you can have, a bigger voltage rating, smaller current, all those things are fine. But 1 kilowatt hour, maybe less than 1 C. Definitely there is another rating will come. So it is less than 100. They're trying to bring down less than $100. Now you can assume that it is equal to $100 US dollar. Say about 75,000 or whatever it is. Assume that. That is the price. Anyway, it is bringing, they are bringing down. Then you think of the cost that is spent for the battery pack, even for a 35 kilowatt hour battery. You just think how much money you have to spend only for the battery. For that cost, we can buy 2 or 3 cars with the IC engine setting. Okay, that is the thumb. Okay, the other things are very simple. Once if battery is done, then you have this transmission. Transmission, most of the case we have the couplings are actually reduced. We don't have like a conventional ICE engine. We have a lot of transmission. So in electric vehicle, the transmission they try to avoid, because the efficiency really improved when you have your the actual drive is very close to the wheels. Then it is really good, and they try to reduce the physical length of the drive as well as the wheel. Okay, that is one. And you have another one is the another main part is the drive. Okay, the electric drive. So electric drive is the main portion next to the battery pack. So electric drive of different natures. You can have electric drive of induction machine. That is the technology by Tesla. They have. Second one is PMS. That is another type. Another motors are coming up, but these two are right now very popular in the category of this electric drive with a very accurate control methods. They use different control methods, vector controls, all those things. Okay. Then you have this DC to DC converters. anyway, you have a motor controller. Motor controller is not just a DC-DC converter. It does so many things. And then you also need these converters for the auxiliary supply. That is another important, because we don't directly tap anything from the main battery pack. In some cases, they use a separate battery pack itself for auxiliary supply. But some cases, they can tap from the existing battery pack. For example, car and all, they will tap from the main battery pack. They have a DC-DC converter, but for a high vehicle like truck and bus, all those things, they have a separate battery for the auxiliary supply. Okay. Another one is the this cooling. Cooling is the very important cooling circuit, because a lot of heat dissipate from the battery pack, from the converters, from the drive. So you need to have thermal balance. This temperature should be properly balanced for all the optimal operation of those components. Okay, so that is one important circuit. The other one is the charger. So onboard chargers are categorized at level 1 chargers, onboard chargers. Generally level 2 and level 3 chargers. Level 2 and level 3 chargers are generally called DC chargers with different power rating. So this is a low power rating with the onboard chargers. This may be some medium power rating. Depends. We cannot exactly spell what is the value of one. And this is the high power rating. So based on the powers of the converter, remember, not energy, based on the power, how much power it can flow from the source to the battery, it is categorized like level 1 and level 2 and level 3. Okay, that is about charger. And the other main portion along with the battery is what is the battery management system. That anyway, it's not a big hardware which you could locate in the vehicle. It's a small hardware with several settings. That's what we call as VMS. Okay, battery management system, where we can explore many things. The battery management system, we have this SOC, then SOH, protection, battery production, and then all the basic protection circuits for over current, over voltage, over temperatures. All those things are very basic. But this SOC, SOH estimations are very important. That is really a very good room for research, that how to predict the SOH, how to predict the SOC and SOH are really interesting part in this electric vehicle. Okay, so the components wise, the electric powertrain components are very simple. If you want to make it very simple, you have a battery pack, and then you have a drive, you have a controller, and then the transmissions are really, you need to have a differential. That's all. If you have a differential, then you can connect the drive very close to the differential, then that will be taken care. Okay, so this is the very basic component, but in that there are many other categories. That you have in-wheel drive motor, where the motor is embedded into the wheel itself. Then you have all the 4 wheels are actuated, 2 wheels are actuated. Those are all different category of the different drive technology, all those things. Okay, that is the minute things on the vehicle, but we are not looking into that in this particular lecture. Okay. If you have any doubts, please you ask in that. I give you 5 minutes. If you ask, then we can proceed further. Okay. So this is the comparison of IC engine vehicle, electric vehicle. So IC engine vehicle, you have an engine then connected to the transmission, and then to the differential you will simply connect through transmission, either automatic or manual. But in electric vehicle, you have a battery, then differential drive and electric drive. That's a very simple comparison. Okay. So this is what a simple block diagram of how, if you want to represent this as a block diagram, and this is what the simple block diagram where you may have a charger here. So just plug over the supply and then, okay. So it goes here. Then you have bidirectional flow. Flow from the, that's why it's called motor bar generator, because it may have a regenerative capability. Regeneration is possible with this drive. And then you have a transmission, and you have a differential here, and it is connected to the wheel. This is a very basic the powertrain component. So the power flow comes from here, and then it will go to the battery, and it will go here, and it will go here, and it will go to the wheels. It's very simple. But if you want to have a regenerative, the regenerating power also comes from the wheels, and it will flow in this direction, and it can go to the battery. That's it. But if you want to have this thing from battery to grid, that is not possible in the present day vehicle. Maybe electric train, electrical locomotive, it is possible because it is always, while running, this connect to the grid. So two part we have to think. Okay, regeneration flow is fine. Right now we can think of a regeneration flow only to the battery, because when the regeneration is possible, only the vehicle is in action. The vehicle should run to have a regeneration. You have to stop the vehicle. But then you can also think of the flow back to the grid from the battery. That is also possible when the vehicle is parked. Okay, so that is because we are not taking the scenario where the vehicle is connected to the grid and it is running. But those also one of the topology, but that is not in more in percentage. But there are some highways near Delhi. They are thinking of like tram car. So they have a electric line. So you have a actually you tap from those lines, and the vehicle. It's a very particularly designed highway. Only the trucks will flow here and there for a very defined transportation. But when they try to the truck go away from the highway, it have to use their own battery. But till then they can use the overhead lines where it is tapped. Those things are very special case. But right now, what we mean by the flow from battery to the grid is called vehicle to grid technique. Okay, and the normal charging is what we call as grid to vehicle. So these two things, I hope some other teachers could cover this portion. Okay, vehicle to grid and grid to vehicle. So this is also a very good research topic one can explore. Some of the researchers try to do something on these things where many techniques should be adopted to proceed with vehicle to grid, because we don't know what is the SOC level, how we ensure that when we try to take our vehicle for the trip, we have to ensure that the minimum SOC level for the battery. So either it need to charge or it need to discharge. Okay, and the vehicle is parked in your parking lot, and you want to run through this operation that either you charge or discharge. But the scenario says that it is not in our hand. We have to just leave the vehicle. The vehicle could be, for example, a 12 hours gap. The vehicle could be charged or discharged based on some pattern, such that at the end of, the starting of the next day, whatever you set for the battery SOC, it should be there in the battery for your trip. For example, you leave at 10% SOC and you want 90% SOC. Okay, so this is the initial SOC, this is the final SOC. Then the case is how to, you can immediately charge from 10 to 90%, but that is okay. But by some time you need to charge from 10 to 30%, then from again 30 to 25%. Sometimes it's discharged because sometimes the grid demand energy from some source. Then this is what the grid to vehicle, vehicle to grid technology adapted in a single time slot to have. So then 25 to 80 next hour, then next hour 80 to 50, something it should do, but finally it should end up with 90%. In between, whatever it can do, it can go up and down and something it will do, but finally it will end up with 90%, where you don't know what has happened. But finally, the algorithm should set some kind of a benefit to you, either in terms of cost or in terms of something else, without damaging the battery, all those things. So these are all the minute things you can look into this grid to vehicle and vehicle to grid topologies. If you want to do that, is something not related to the dynamics of the vehicle. You just assume that you have a battery in your house. That is the only one scenario. You have a very good storage device with you that could be used for driving the vehicle. But if you park your vehicle at 12 hours, because most of the personal use vehicle, we just go to office and we park it for a long time. So a very good storage unit is with you, and you can effectively utilize that without damaging the battery. Okay, so that's all the different research topic. Okay, so these are all the basic components in electrical. So the battery actually comes with the battery management system. So battery management system also, there are many things you can actually, I'll tell you what is the basic components in the battery management system. Main is the sensors. So all the sensors like temperature sensors, current sensors, voltage sensors. All these sensors are taking signals, and the BMS will simply watch about whether it is exceeding with all the limits. At the same time, it also estimates SOC and SOH. Okay. So this SOC prediction is very important. SOH is, yeah, first you should be familiar with how to predict the SOC. The problem is you all know that, okay, SOC could be simply predicted by just checking the terminal voltage. That's what we all know. But the open circuit voltage, not terminal voltage, you just measure the voltage across the terminals of the battery. You say that, okay, there is a table that tells you that what is the battery SOC. But remember, terminal voltage is something other than, something different than the open circuit voltage, because terminal voltage is you simply measure in the terminal at any time, either with load or without load. But open circuit voltage is just a without load. The battery should not be connected with any of the load. You just measure the terminal voltage without load. It's called open circuit voltage. Yes, then your SOC prediction is fine. But when if you have the load is connected to the battery, then you have to find out from the terminal voltage what is the open circuit voltage. This is the estimate, this is the prediction. So you have to use some prediction methods, either model based or some statistical based, something you have to use to do that. So that's where there are a lot of things, and BMS is also a very costly affair when you buy the battery. Okay, so these are all the main points we could. Okay, so let us look at the rating of some of the parameters. What you could see in the when you compare to the electric car, because our basic design starts from that. But when you try to buy a car, when you try to look at the electric vehicle, what you basically will see, they will give you a pamphlet, and you could see some of the specification. So here is the comparison of how an electric vehicle and a normal vehicle looks like. That's a specification, not more technical, but some simple specification you can always have. One is the fuel type, the diesel or petrol, and the engine size. Then this is also engine size. Then number of cylinders, maximum power. What is the maximum power? And that maximum power will be delivered at what speed, and maximum torque will be delivered at what the speed. That is also very important. Both are very important specification. And what is the maximum speed and cost. And mostly what you will look at when you try to buy a car, you look whether it is diesel or petrol. That is very critical parameter. And you will really look at the cost. Those things you will really look in deep when you try to buy. Other things not a matter for you, whether it is 1.5 cc or 2 cc. And then the other thing what you will really look at is the fuel economy. How much kilometer this will go, or how much money you spend for the trip, or for the range of the kilometer. But when you look at the electric vehicle, these are the specifications. Directly something comes saying that okay, we have the motor power, and you also have a similar specifications: the maximum torque and the maximum speed at what maximum torque at what speed, maximum power at what speed. Those things also you could check. Then the other main parameter is the range. Range is what is very important in the electric vehicle. You will really look how much kilometer I can travel per charge. So range is nothing but this 300 kilometer. You generally write 300 kilometer per charge. Okay. And then ampere rating, all those things are fine. You will never really look at the ampere rating. You will look at the kilowatt hour rating, but then kilowatt hour rating is reflected in the cost. So that also you don't look much. You only look at the cost. Oh, it is 17 lakhs compared to 11 lakhs. And then what is the point of referring to kilowatt hour and then nominal voltage of the battery, motor type? Who knows? Who cares about the motor type? All those things. One is the range, another one is the cost. Okay. You don't worry about what is the motor power, because you don't know what this motor power 95 kilowatt will do what. You don't know that. All these things finally will be linked into the range. Okay. So this range somehow will be linked to the kilowatt hour rating. This kilowatt hour rating will be linked into the cost. So you devise or you size the battery, and then the cost is also actually involved with that. Then based on the battery size, the range will be fixed. That's very important. But in between, you should know how much unit you need to run the vehicle at 1 kilometer. So these are all highly related. So we are going in that way, step by step, how much energy you need to drive the vehicle. So one is the cost. Anyway, you forget about that. We cannot guarantee anything about the cost. Start from, if you want to do a reverse calculation, you start from what is the battery size. Once you know the battery size, you should know how much unit is spent to travel 1 kilometer average, because for that we should know the drive pattern. That's what we call is the drive cycle. It's a velocity profile of a vehicle for a difference value. Then that will tell you how much energy you need to do this, to complete this drive cycle. Okay, but if you want to know how much energy you need to drive the vehicle for that particular drive cycle, you should know how much power it is required for each and every second, how much power you spend throughout the cycle. Then you take the area under the curve of the power versus time. That will tell you how much unit you need to complete the cycle. That is a rough idea. It will give you a rough idea about that particular drive pattern. That's why every time when you check the vehicle, when they say that this vehicle will give 21 kilometer per liter, then they put a star. So this is for the test condition. It is not the condition which you really drive the vehicle. This is their test condition, but we don't know what is their test condition. It may be for a particular drive cycle. Okay, so for a particular drive cycle, this will go. Same procedure here. Particular drive cycle only, it is calculated how much, rather kilometer per liter. Here we'll ask kilometer per unit. Okay, so the thumb rule says that if you have 10-ton vehicle, the vehicle weight is 10 ton. That's a simple calculation I'll tell you from the specification itself. We have not explored much. I'm just to explain you from the simple specifications what you look when you try to buy an electric vehicle. And this is especially for Tata Nexon. The specification is taken for Tata Nexon vehicle specification. Okay. From this, I'll slowly try to develop a calculation. A simple calculation says that. So you can keep in your mind that 10-ton plus vehicle plus not much, 10 to 12 ton if you have the weight of the vehicle. Somehow the rules, the thumb rule says that this weight vehicle should not take more than 1 unit per kilometer. To take not more than 1 unit per kilometer. That is the thumb rule. Now you can scale down this. Now if you have a vehicle of 5 ton, it should take only half a unit per kilometer. If you have 2 tons, then it's just 0.2 unit per kilometer. It's not really correct, but this is what they try to expect you. Suppose you are saying that I have a power train, all the components I design, controllers, drive, everything I design. When I do the test, when I do the study on the vehicle, somehow I find that it is taking for 3-ton vehicle. 3-ton vehicle. They simply say that it takes 1 unit per kilometer, even though it looks nothing, 1 unit per kilometer, because even if you spend 8 rupees, it is 8 rupees per kilometer. That is, suppose if you have 21 kilometer per liter calculation, this is really seems to be large. That you are spending 1 unit per kilometer, that 1 unit is 8 rupees. Then you can do the reverse calculation. So even some of the government rules, if you try to design some of the vehicle for the government, the rule says that 10 to 12 ton vehicle, it should not more than 1 unit per kilometer. If it's less, it is there very happy. That yes, sir, this vehicle is having only 0.5 unit per kilometer for a 10 ton. So then you can calculate now 30 kilowatt hour battery, the range is 300 kilometer. So 30 units 300 kilometer. Then 1 unit is 10 kilometer range for this vehicle. By looking at the specification, you can check. It says that 1 kilometer, 1 unit, you can drive for 10 kilometer. Seems to be really nice. 1 unit. Then 1 kilometer, if you want to drive, it takes only 0.1 unit. The way they specify the range and kilowatt hour. So kilowatt hour is the battery rating. Approximately 30.2, okay, 30 unit. If you do a full charge, it is 30 unit, but you can travel 300 kilometers. Really a nice, factor that is projected here. So everyone will tend to buy the vehicle, but we should know how it really takes 0.1 unit for 1 kilometer. For that, we should look at the very basic steps that is involved with the design. Is that clear? Because this is the simple points which you should pick from the specification for the component design. Is that clear? If you have any doubts, please you can ask at this stage before we get into the design. If someone responds, it will be good. Otherwise, it is highly monotonic for me. That and
no doubt, sir.
Looking at some screen, I am talking to the computer.
So there was a question in chat box: peak power and nominal power. How to find?
Yeah, someone, I don't know how to. The chart box. I have to go check the chart box.
So I will read the message, sir.
Yeah, rather if somebody if they themselves ask, it will be good, right?
Yes, sir. So how to find the peak power and nominal power?
Yeah, that anyway will come.
Yes, sir. Then
Yeah,
how to reduce the cost?
That's what next we are going to do.
Yeah, okay.
But before that, I just would like to know any feedback about those fundamentals. That is the design part. The peak power calculation and nominal power calculation we are going to do it now. Yeah, there is a question by Sankaranarayanan, right? To reduce cost, can we interface battery and solar energy? Yes, you can interface, but the amount of the energy contributed by the solar panel to the vehicle, that too especially the vehicle when it is moving, it will be very less, but yes, that is always possible. Is that clear? Is it okay, Sankaranarayanan?
Yes, sir, it is. Yeah, hello, sir. I'm Shija. And yes, sir, I understood. Sir, my one more question I have on the similar line. Sir, along solar power and wind, can we interface both this along with battery? I mean, suppose if it is summer or if it is very hot, then the load is driven by solar, and if the vehicle is in a movement, then wind, and then if it is at rest position, then maybe battery, or when these renewable resources are not available, then we can take the energy from the battery. Can this combination work, sir?
Yeah, it works. See, unless otherwise, if the vehicle carry the panel, they compare to the rating of the battery. The space available in the vehicle is very less. If you want to mount the panel to the vehicle, okay, that is one scenario. But if you want to utilize the solar energy for a vehicle charging, or even solar panel paved roads, those are all the advanced concepts. Okay, so you can use solar power for charging the vehicle through many ways. Somewhere solar plant could be there, you can interface with the grid, you can charge the energy from the grid point anywhere. That is one scenario. But solar panel paved roads and then wireless charging that takes energy from that paved road, those things are very advanced concepts. Is that okay?
Yes, sir. Thank you, sir. Very much okay.
Okay.
Sir, I have one question,
Yeah.
sir.
Yes,
Good
yes.
afternoon.
Yes.
Sir, how the battery ampere hour rating is related to the state of charge, sir? We are measuring the state of charge.
Ampere hour rating is not related to the state of charge. Even you take any ampere hour rate, if it is full. For example, if you have you have to look at the kilowatt hour, the rating of the battery, because voltage could be anything, right? So kilowatt hour, if you have 30 kilowatt hour battery, if 30 kilowatt hour the battery is full, 100% SOC means you have 30 kilowatt hours stored in the battery. The battery is full. Nowhere
Okay, sir.
ampere rating comes to picture.
Okay, sir.
Because you have 1 kilowatt hour battery. The battery is full means you have 1 kilowatt hour. You can spend now 1 kilowatt hour.
Okay, sir.
Yeah, the ampere hour rating will come into picture when you do other calculation. For example, power rating if you want to. Okay, so when you do a power rating, if you have 100 ampere hour battery means it delivers 100 amps in 1 hour. Okay, if the rating, if the C rating of the battery is 1C, that anyway I'm going to cover. So you come to know that. But SOC is not related to your ampere hour rating. None
Sir,
of
here
our
the maximum.
Yes.
Yes, sir. Yeah, understood, sir.
Okay.
Thank you, sir.
Yeah. Anyway, we'll see. We'll have a separate question and answer session. Okay. Okay, and these are all the simple calculation which was made long back, but still it is useful to have that how much the money calculation related to the conventional licensing vehicle. But anyway, everyone convinced with that. So this calculation, because when I do this calculation, 1 liter diesel is 65 rupees, but now I think it is more. So still this figure will be giving you a motivating factor, but forget about that. That's not very important. And the drawbacks you should know, because these drawbacks will tell you that in what area you can look into more research scope. One is the battery life. Okay, battery life is very important because it says roughly 4 to 5 years.
Sir, one small request.
Yeah.
If you can increase the font size, then I think we can. I mean, I'm not able to read it properly. Font is very small, sir.
I don't know whether you are looking at the computer or the mobile.
Computer, sir, but this font is very small.
Okay, is that okay now? Is that okay now?
Yes, sir. Yes, sir. Okay.
Yeah, like that I can make a full screen. Okay.
Thank you, sir. It's
Yeah.
visible. Thank you.
So 4 to 5 years, the rough for this. But then again, this 4 to 5 years depends on many factors. Okay, the number of cycles. Sometimes if you use heavy number of cycles, then the lifetime will come down. So that's what I said. This is something related to the state of health of the battery. This is very important. Now the recent Apple comes with a very good estimate of SOH. That anyway we'll see. Time is there, I'll tell you what is that. Okay. Then the cost of the EV is around 2.5 times higher than the ICE engine car. That is true. But again, that is because, as all of you know, that the efficiency of all these power quality converters, drives, and if you have your drive very close to the wheel, the transmission efficiency is also really large. Then there is no point on keep on increasing the efficiency from 85% to 89% or 90%. It won't make much impact on the cost. The cost of EV is really large is because of the battery. not anything else. But that is okay. Even if you're ready to spend this much amount of time, the another one is the charging time of the battery. 6 to 8 hours if you have level 2 charger. Okay. If you have with level 1 charger, it go 12 plus hours. Okay. With level 1. But it can be less than 1 hour or 1 to 2 hours if you have level 3 charger. But study says that if you always charge the battery with level 3 charger, okay, your battery life will be less compared to charging with level 2 and level 1, even though you have the proper C rating of the battery. So you have to first of all make sure that you have a proper C rating to accommodate all these level charging for a battery. Suppose we say that you have a C rating is not allow you to charge the vehicle battery with level 2, then you cannot charge. If you charge, your battery life will go down. That you could have experienced when you try to charge your mobile. Maybe when you try to charge your old mobile with a new charger. Okay, the new charger power rating may be more, but you try to charge your old mobile with a less power rating. So you should be very careful about the power rating, even though it may quickly charge for 1 or 2 times, but later you slowly, your state of health of the battery will come down. That correspondingly reduce your life of the battery. Okay, same concept is followed in the, because see, the lithium ion battery charging profile and the charge pattern, everything are same for whenever you use your lithium ion battery, either for your mobile or in your vehicle. Since the vehicle batteries really cost you more, you need to have you have to take care about these patterns, and your cost is highly involved in that. You don't want to damage your battery, right? Mobile battery cost is very less, but vehicle battery cost is 60 to 70% of the vehicle cost. Suppose if you buy a 17 lakhs vehicle, almost 10 plus lakhs you spend for the battery. So you don't want to lose the battery. So these battery management systems and battery protection, all those things will be very much useful to save the battery life. That is directly coupled with the cost. Okay. Another one is the, okay, even though you have all this facility, another one is the infrastructure. Okay. Recharge stations. That is very important. Even though you try to spend money for electric vehicle, you try to buy a costly battery with a higher C rating so that level 3 charging the vehicle, the battery accepts. But you need to have lot of recharge stations. That is the infrastructure that you cannot develop overnight. Okay, so vehicle manufacturers will not really worry about all those things unless otherwise there is a business model that tells them that okay, these are all coupled. Okay, so this is infrastructure level development we should have. Another one is the range of the EV limited to few hundred kilometers for a single charge. That is another drawback, because if you fuel your tank in the IC engine vehicle, just for a comparison, it may take maximum 5 minutes. 5 minutes you can fill up your tank with 40 to 50 liters of gas. Then you see with that you can travel. If you have a very good vehicle, very economic vehicle, you can travel about 750 kilometers. You can travel with one full charge within 5 minutes. Forget about the cost. This is where the comparison. You spend about 6 to 8 hours for a single charge. Then you take the vehicle for 300 less kilometers for a charge. Those are all the worrying factor. Okay, so that too, level 3 charge, okay, you will charge 1 hour, but 1 hour still is very large, right? Compared to fueling your IC engine vehicle in 5 minutes. 5 minutes, even not more than 5 minutes. More than 5 minutes if they take, we feel angry with the fuel pump guys. But if electric vehicle, best case you can do with 1 hour and less than that, depends on the C rating. But when you try to pend such a C rating batteries, it is really cost you like 2 or 3 times more than the actual cost. Okay, so these are all the factors you should really look to overcome. So these are all the these are all the points will tell you that how you can do kind of a research and, to reduce that. Okay, so these are all some of the motivating factors. We will go to the actual design. Okay, okay. So as I said to you before, the basic design starts from we are actually trying to calculate how much energy we spent, how much. So we basically start from the battery size. If you divide R simply, we want to know how much unit electric vehicle consumes for 1 kilometer travel. This is the one-line question that you can post. Question number 1. You want to know how much unit the electric vehicle consumes. Unit is 1 kilowatt hour. Okay, or kilowatt hour. You want to know how much kilowatt hour the electric vehicle consumes for travel this 1 kilometer. This you want to know. This can be divided into 2 problems. One is for a specific pattern, velocity. Another one is for a given proper drive cycle. Drive cycle in the sense city drive cycle, Chennai drive cycle, Mumbai, Delhi, Kolkata, all the there are drive cycles. If you are inside your highway, that can be taken very easily. That's not an issue. Okay. To proceed that, to solve this problem, we will go from the very basic steps. Okay. Assume that this is the simple model of the electric vehicle. That is, again remember, this is not for electric vehicle, even for a normal vehicle. Okay, so assumes that the vehicle is traveling at this speed and the wind velocity comes in some direction. Could be sometimes helps you, sometimes this arrow mark doesn't matter. There is some wind gust that comes through any direction. Okay, and assume that the vehicle is relatively with this point, very important. You have to take some point that is very close to the time, this theta. Suppose if you take a bridge, you cannot calculate this theta from the starting of the bridge. If you say that, sir, the bridge is very steep, it's a 45-degree slope. Whether should I have to, this theta is 45 degree? No. This theta is the slope just taking a reference from maybe few meters behind your vehicle and you have to calculate this theta. Okay, that is the convention. Remember this. It's not from where it starts few kilometers before. Okay, and this is the the weight force vectors. This is m, mass. The vehicle mass is m, gravity theta, all those things. Okay, so the basic idea is to calculate how much force you need to move this vehicle to follow a particular velocity. That's what the first calculations. Okay, so we'll try to calculate. This is the tractive force, Ft. I hope the slide is visible to everyone. And then we try to apply a force through somehow. Either you push the vehicle or you apply this force via wheel. That is not a matter now. The tractive force F of t is required to push the vehicle such that the vehicle is moving at this particular velocity. Okay, and the velocity could be anything. The velocity may be constant or it could vary. It could be increasing, decreasing, doesn't matter. I have some v and I want to know what is the force that really cause for that particular v. Okay, so F of t is the tractive force. And I have to calculate all the resistive force. What kind of resistance? When you try to push the force, how many forces will resist you, will not allow you to push into this particular direction? That you have to calculate. Okay. One is the drag force. One is the drag, that opposite force because of this wind velocity and due to the air motion. Okay, so we don't get into all the aerofoil structure, all those stuff. There is something called a drag force that actually opposes the motion. Okay, so that comes from the fluid mechanics. You don't need to get involved in all those stuff. Okay. Okay, so this is the drag force. So this much force will oppose. That is proportional to the drag coefficient, air density. Rho is the air density. A is the frontal area of the vehicle. So that's why you see, if your frontal area is really more, this drag force is more. And the drag coefficient is how much it is scaled in terms of the velocity. So this scaling factor is the drag coefficient. That depends upon the shape of the frontal area. That is also important. What kind of aerodynamic foil or aerodynamic profile if you have. All sports car, if you could see, the CD is very less. We all try to reduce the opposite force, resistive force through this. Okay, this is one force. The another force is the tire friction. Okay, tire friction force, that is actually will be written as mgcr into cos theta. This is the tire frictional force. That is also resisting. So simply, or it's called rolling friction. Rolling, especially rolling friction is called. Okay. So this tire friction is actually calculated based on the there's a friction coefficient, okay, and just the mg the weight force, and friction coefficient cos theta is fine. That will not affect too much. So generally, most of the cases they will write mgcr. That is so you think of now how much force. Suppose you need to remove some of the force to move the vehicle. Assume that there is no wind velocity. The vehicle is moving. So how they calculate? They apply a force. They measure the velocity. They remove all the other forces. The remaining force actually is used to calculate the tire frictional force with this friction, rolling friction coefficient CR. It is very simple. You scale the weight force. The weight force is highly proportional to the frictional force. That's all. And the proportionality constant is nothing but CR. So you take a weight force, some amount of restriction comes that is directly proportional to the weight of the vehicle because of the rolling, because it is connected in the row by a wheel, right? So some kind of theoretically speaking, it is called rolling opposition. It is not really called friction because theoretically speaking, the point of contact with the wheel to the road, theoretically speaking, it is zero. Theoretically speaking, otherwise the vehicle will not move. So theoretically speaking, there is no friction. But that is not the real scenario. Your vehicle tire has some kind of a flat motion, some kind of a flatness you could see. When the speed is very less, you could see it's some flat. But it really moves very fast. It's really it's point contact. Okay, but then some kind of a force resists the motion. That is directly proportional to the weight. That's how it is calculated. That's how the CR is calculated. This is the practical way of calculating the CR. Okay, this is the tire frictional force. Another one is the force due to the weight. That is the slope. That is the slope of the vehicle. Is theta. If theta is 0, there is no any opposite force. You need to apply more force when you want to climb. It is because of what is weight. But any object, not tire or something else. Okay, that is what we call the grade. The resistive force due to the grading. Grading is like you are moving on a grading slope. Okay, that is the due to slope. That is nothing but mg directly scaled by sin theta. So if you have something like that, if you could mark. So this is mg sin theta. This is mg cos theta. All the 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 weight force is split into two components. This is 90 degree. Okay, so these are all the main resistive force that oppose the force which you try to apply for the vehicle. If you could remove all these force, then the vehicle will move in some velocity in the forward direction. That's all. Okay, so we can sum all these things. So you apply a force, then you resist, all the resistive force will try to oppose this. The remaining force, the tractive force minus the resistive force, will the cause for the vehicle to move. Okay, so that is nothing but Ft minus Fr, all the resistive force, is equal to m into some alpha. So what is alpha? It is acceleration. So alpha is nothing but dv by dt. It's very simple. It's acceleration. Okay. Now if you put everything together, we could write the tractive force Ft is equal to mass into acceleration plus it's split into different components. First we'll write the drag. Plus the rolling friction plus gradability. Okay, this is the main formula. Very simple, basic. Again, remember, in the practical scenario, there are many other terms which actually added with that. Okay, so, but for a simple design, it is sufficient to have this formula. So, you need this much force to run the vehicle at this much velocity. And if you have the vehicle is the velocity profile, if you want to accelerate the vehicle, yes, you need to simply scale by this mass. That is momentum. That much force you need to accelerate if you want to accelerate. And this is the drag force. This is the rolling friction. It is comparatively very, very less compared to all other things. And if there is a slope, this play a very big role. When you are driving the vehicle in a slope, yes, this mg sin theta plays a big role. Otherwise, this is a very simple thing. For example, if you make this theta equal to 0, you are not traveling on the grade, so there is no slope, straight plain road, and the vehicle is not accelerating, v is constant, then you can simply calculate what is the tractive force. The tractive force is nothing but, for this case, f of t is equal to, only to reduce the drag and this rolling. That's all. And compared to that, rolling friction is very small. So that's what we call cruising. When you cruising, this means constant velocity. Only this two, you apply a force that is needed to reduce only the drag as well as the rolling friction. That's why when you cruise with a constant speed, the fuel economy is very good because you don't put much effort for the vehicle to move to a particular speed. Okay. Now, so what is it? From here you can calculate the power. Power is nothing but your force into velocity. That's it. Okay. So you have f of t, you have v of t, all the function of time. Okay. So you have f is a function of time, v is a function of time, and then you have p is a function of time. Then it is very easy for you to calculate the energy. It's nothing but you integrate, starting from some t0, some t final, p of t dt will give you the energy. So this is where we are going to calculate the energy. So for that, first you need to plug into this formula. What you need to know the theta value, that is a variable. Mass of the vehicle, we don't take it as a variable because it is, you can take an average value. G anyway, of course, is not a variable. CR is the constant for a particular vehicle that is you have to get from the cable. G is a constant, M is constant, velocity is not a constant, CD, A, rho, M, everything is constant. So the variables are only V, unless otherwise theta is varying much. V is the only parameter we should know, that is the variable to compute this force F. That V is nothing but what we call as the drive cycle. Okay. Now, somehow we have to get the V of t. If you know V of t based on other values, for example, mass, G, CR, all constant. G, CR, what else? Area, CD, all are constant for a specific case. If you know, if you have V of t, yes, plug all these things, calculate F of t. Okay, then subsequently calculate P of t, then we calculate the energy. Is that clear? Then how we can calculate now the unit per kilometer, we calculated energy, right? How much energy consumed. Then we have V of t, the velocity profile. What you do, you just integrate V of t. Okay, you will know the distance, say x, starting from some t0 to t. If you know what is the initial, the value of the position, if you know that, yes, you can calculate the x. What is the x? Is a distance. So now you have mapped how much energy you spend to travel a particular distance, V of t. And you are going to have a V of t for a particular time. So in graph, what you are going to have is a V of t. You are going to have some kind of it's not the actual profile, will tell you what it is. So this is what the basic calculation what we did. Okay. Is that clear? If it is clear, I can proceed further to have put some example and some more minute points. So from here we have to split into two parts. One is for all the peak power calculations. Another one is for the real range calculation. One is the peak power. We want to know what is the peak power. For that we have to take some specifications. Okay, what is those specifications? I'll tell you. One is the actual specification. Okay, the simple specification when you look at, will always write the acceleration. So the maximum acceleration of the vehicle. Okay. Well, maximum acceleration in the sense the acceleration specification. So they will write that, okay, 0 to 100 kilometer per hour in 10 seconds. If you see any vehicle specification, they will always, it is nothing but the maximum acceleration. So yeah, you can take 0 to 100 kilometer per hour in 5 seconds. That is okay, it is up to you. Sorry, 15 seconds. But this is the maximum acceleration value. You have to accelerate the vehicle from 0 to 100 kilometer per hour in 10 seconds is the maximum acceleration. So you need to have some power, or you need to have that much force to push the vehicle from 0 to 100 kilometer per hour in 10 seconds. So at 10th second, the vehicle speed is 100 kilometer per hour. Okay. Based on that, you have to set the velocity. You are going to cook up a velocity profile that says that if you rise if you start from 0 time and if you raise the velocity, it should reach 100 km per hour in exactly 10 seconds. Is that clear? Okay. Then they also write the maximum speed of the vehicle. Okay, maximum speed maybe we'll say 200 km per hour. So the vehicle should reach 200 km per hour is the maximum speed. This is the acceleration. This is how you rise the speed. For example, 0 to 100 km per hour in 10 seconds. But you can reach 200 km per hour speed. The maximum speed should be 200 km. Even you can reach 200 km per hour maximum speed with this acceleration or something else. What should be the worst case? You can take the maximum acceleration to reach 200 km per hour and then you keep constant. Okay, so these are all the specifications written in all the vehicle. Acceleration specification and maximum speed. The third one is the same specification is written in written with some grading. You can with slope. Okay, it's the same. So maximum acceleration in grade. Grade is it is scaled to 90%. There is no slope beyond 90%, right? So it is scaled 90 degree 100%. Then you can so grade is, for example, say 30% grade. Then there are specifications 0 to 50 km per hour in 5 seconds. Another one is the maximum speed on the grade. You will write 30% grade. It is say 100 km per hour. Yes, you cannot expect the same speed with some grade. This is maximum grade. This is the separate specifications given. This is for a normal plane. This is with grade. Now you have to check. So you have a V of t is given. You can cook up a V of t. For this also you can hook up a V of t. This 2 V of t you can plug into that force calculation with this case. Theta equal to 0, theta equal to, based on this 30% you can calculate, maybe 15 degrees or something like that. Is that clear? So the basic idea of all the specification is to build or is to cook up this V of t. So one is to calculate the maximum power. One is to calculate the nominal power. These are the two calculations. So nominal, I'll tell you. So the maximum power calculation, you have to take specification like maximum speed, maximum acceleration and grade. Okay. But the nominal power calculation, you have to take the actual drive cycle. Not this. This is for the peak power or maximum power or peak power. Okay. So peak power calculation, we have to take all the worst scenario that I have to push the vehicle with the maximum acceleration and I drive the vehicle forever with the maximum acceleration. I want to know what is the maximum peak power it takes. So I have to size the motor with that maximum peak power, that meet that maximum peak power. Definitely the nominal power is less than the maximum peak power, but nominal power calculation you have to meet the actual drive cycle. Actual drive cycle is a proper drive cycle. Maybe there are many apps now in your mobile. You take a trip, you start your vehicle from home and you plan for a trip, you switch on the mobile. That mobile captures the velocity from GPS and it will completely give you your velocity profile till you stop your car for the trip. That is your V of t. That is the real drive cycle. Now you can calculate what is the travel, how much distance you travel and how much unit it is consumed. That's it. That will give you exactly how much unit it consumes for that particular drive pattern. For particular drive pattern, how much unit it consumes. That is a real calculation, practical calculation. But here in the theoretical calculation, we hook up a drive cycle. Maybe you take that drive cycle, plug into this formula, and then you check. Based on your mass, other things, it will give you a power. Then you plot your power curve, or you integrate the power with respect to that some time, and you can calculate what is. This is what the actual calculation goes like. Okay, so peak power either occur with this rating or sometime with this. Then you have to go with which one is higher. When you do a calculation, you have one V of t for the normal plane, another V of t is for the slope. You plug into that formula, you have a different graph. Then with that, you have to find out the peak power. That peak power will tell you that what is the which one is more, either for a normal plane or for the grain. You pick the one which is higher, and you calculate you have to select the power rating of the motor with that nature. That is the peak power. So all your torque speed characteristics should fall under the torque speed characteristic of the this what you are going to select from your force and the force calculation, and from the force you can simply calculate the torque if you know the wheel radius. That is going to develop that much torque. Okay, so these are all the basics. I don't know how much time I have more. I don't know whether I could be able to show calculations for both the case, but this is the idea if you want to have it. Can someone suggest how much time I have? I think I almost am completing.
Sir, as per schedule, we have to complete by 4 p.m. sir. So you can take, sir. I
have only 5 more minutes. So if any questions answer I would like to have, then it's fine. Otherwise, yeah, if you have questions, please ask. Because if the deadline, the time is very strict, then I have only 5 more minutes to invite some questions.
Sir, if you want, you can continue, sir.
Okay. Maybe I will show some bit calculation, then you come to know what it is actually. Okay. So for a peak power calculation, we'll take a particular profile. For example, you take the first case where this is the say this is 100 kilometer. So we will take 10 seconds to 100 kilometer. Okay. Then also, if the same acceleration, if you continue, it will go to reach. This is 10 seconds. This is 20 seconds. So in 20 seconds, this is the worst case. In 20 seconds, you will reach. This is the 200 kilometer. So this is the worst in the sense, this is the drive cycle should be used to calculate the peak power. Okay, and exactly the peak power occurs at this point. I think that much you can understand, right? The peak power exactly occurs at 20 because 20, the maximum speed occurs at the same time with the same acceleration. So the acceleration is constant till this point. After that, since the velocity is 0, the acceleration is 0. So the force which is used to accelerate the vehicle contributes its maximum value at this point. After that it is 0. After that it suddenly comes down to 0. But then after that it is a cruising speed. After that m alpha term will actually go off. Assume that theta equal to 0, only this term. This follow anyway constant throughout, unless otherwise for mass is 0, We cannot avoid this term, so it is like a constant term. This term is like your v square term, that is based on your velocity square. That is anyway, every time the velocity is a variable here, after that it is constant. So till this it is a variable, after that it will give you a constant power, the force. So if you split the force into 3 graphs, this is the rolling. If you take FR, this fellow is constant. Some value it is always constant. This is your FD, drag force. If you see, this is going to be constant after 20 seconds, but after that, before that, it has some different values and it will come to a constant. And if you take the F acceleration time, so the F acceleration is constant. So that force is actually called as m into dv by dt starting from 0, and after that all it is constant. But then after this 20, it will become 0. So you see, this is a constant value, this is a variable, this is a constant. So the peak occurs exactly. If you add up all these things, you will have a force that looks something like this. Total tractive force, if you have, exactly it will be something like that. So this is the force that all the other terms, exactly peak occurs, peak will occur, then this will come down, then after that it will become constant, because this constant is nothing but cruising speed. This point we have to take. If you have this point, or directly you can plot this P. The P of t itself, if you plot, this power point we have to take. This point is the peak power. Now you pick your motor size. This power says that okay, it is 200 kilowatt. Now you have to take 200 kilowatt motor size. Peak power. Or repeat the calculation with this mg sin theta, because with the slope theta equal to, say, degree, if it is 15 degree maximum. You repeat the calculation, you may get another graph with P of t, similar. The speed range could be different in that case, but simply look at when the peak occurs. Forget about the time. We don't know the peak occurs at 10 seconds, 20 seconds, 30 seconds, doesn't matter. I want to know only the peak. This point you take. Suppose if this is says at 210 kilowatt, yes, then you have to select the motor 210, because it should match for both the cases. Otherwise, simply select 250 kilowatt power motor. And you have to make sure that you have to, when after this power calculation, you will come to know how much energy you spent for this particular case. But this calculation will be very much useful to calculate the peak power of the motor, not to calculate how much energy you spend to travel 1 kilometer, because this will never give you the exact calculation of the distance, because this is the cooked up profile to calculate the peak power. You are not going to use this velocity profile, or your vehicle is not going to follow this velocity profile forever. So this is not the calculation for the nominal power. This is for the peak power. Nominal power calculation, you take a proper drive cycle. You start the vehicle, you accelerate, okay, then you go with some constant speed, then further you little bit accelerate, then some constant speed, some deceleration, then again cruising, some deceleration, then some cruising, acceleration, some deceleration, then some deceleration, stop. So you can divide this drive cycle, real drive cycle, into for the nominal power calculation. You can divide it into acceleration, cruising, again acceleration, again cruising, again deceleration, D, and again it is rest. So you can divide into acceleration, cruising, deceleration, and then rest. All 4 category you can divide. This any portion of the drive cycle is divided into all this part. Then for each part, you can calculate the power. How much power it is. This is the proper typical drive cycle, real drive cycle. Then it is very simple. Either you divide portion by portion or simply plug this V of t into the formula, plot your power. Any point, it can go increase, it can come down, some kind of. Simply calculate the area under the curve. This will tell you the energy. And if you integrate, this also will tell you how much distance you travel. That will give you the actual calculation for how much energy it takes to travel. Then from that, finally what you have to do, motor sizing you can done by the peak power calculation. Battery sizing, if you do, battery sizing comes from the nominal value. Battery sizing is just kilowatt hour sizing alone. So you somehow found that, okay, it takes 0.5 kilowatt hour per kilometer. Okay, fine. Now you calculate. So you want to go with 100 kilometer range. Then you need 50 kilowatt hour battery per charge. Then you can travel 100 kilometers. 50 kilowatt hour battery. Just a kilowatt hour rating. Then now you come to your ampere hour rating or power rating. How? We have calculated 200 just for this calculation, not a real calculation. 200 kilowatt power we want. Now 50 kilowatt hour battery. So the power rating of the, because your motor power is 200 kilowatt hour, kilowatt, so not kilowatt hour, kilowatt. But your battery is 50 kilowatt hour. That is okay. That depends on the range. But whether will it deliver 200 kilowatt at some time, we don't know, because the vehicle demand any time 200 kilowatt power. Is it possible for the battery to deliver 200 kilowatt? If it want, then your C rating of the battery should be 4 times. That's 4C. Because your output current should be 4 times. So 50 kilowatt hour battery with 1 C rating will deliver about 50 amps. So suppose if you have a 50 ampere hour battery. Okay. So 50 ampere hour battery, if it is delivered 50 amps. So after 50 kilowatt hour, you have to calculate the ampere hour rating based on your voltage. This ampere hour, from ampere hour rating, you have to calculate your how much current it delivers. So 100 ampere hour battery if you take, if it 1C implies that it deliver 100 amps, but that is okay. But again, finally you have to calculate the power because it has to deliver 200 kilowatt. You have to look at the voltage rating of the motor and voltage rating of the batteries between many conversions. So finally, if you have a mapping of your, this is a very rough calculation, but you will never end up with 200 kilowatt. That is the peak power. Okay, but you have to have the battery rating that should deliver the peak power at any time, because it may demand. So that's how you size the battery for the kilometer calculation, but you size the ampere hour rating and voltage rating and C rating based on the power, peak power of your motor. Otherwise, you have to demand, you have to sacrifice on your acceleration constraint and speed constraint. For example, you start from, no sir, I have only 50 kilowatt hour motor. Then you do a reverse calculation. For the 50 kilowatt hour motor, what should be the acceleration constraint and the speed constraint? Then based on that, you set the specification, and then you calculate the how much energy it takes for a particular drive cycle. Then you devise your battery. So these are all interconnected. Okay, but the basic design actually starts from giving this constraint and the real drive cycle. So they will give you this specification. maximum acceleration, maximum speed in both plane and grade, and they should also give you a particular drive cycle. The vehicle is going to be used in some hill stations, or it's going to be used in city for a specific design. Otherwise, they will take a very ready-made drive cycles and they try to do all these calculations. I do have a lot of slides with the actual calculation, but I could not show you in a single lecture. There it is clearly for 3 or 4 example is taken, and it is solved for how the peak power is calculated, how the nominal power is calculated, how to devise the motor with its torque speed characteristics. All those things are there. It will be possible in some other time I can tell you about the things clearly.
So question from audience, you can ask.
Yeah, this is actually a very basic portion, but there are many things related to vehicle to grid, grid to vehicle, BMS, and many things are there. If you really get into the minute things of electric vehicle, there are many things are really hidden, where many manufacturers will not reveal what it is. Yeah.
Hello, sir. This is Subhashish Das. Sir, if we compare with the conventional IC engine, how reliable is the electric vehicles?
Reliable in the sense what?
In terms of performance, power, everything. If you correlate, how reliable? Because now electric vehicles are being thought of due to reduction in emissions. Basically, reduction in emission and depletion of this conventional fuel, that is diesel and petrol. So,
see, if you look at the emission portion, okay, reduction is emission is not a truth.
Okay.
It's not true, because you have to consider the emission as a whole. Now, that's what I said in the initial time itself. Tailpipe emission is less, and no tailpipe emission. There is no emission from the vehicle. But somewhere emission is produced, right?
Okay.
When you drive the vehicle, you are using 30 unit. So where the 30 unit electricity is generated, unless otherwise it is purely generated from the renewable sources. Still emission is there somewhere else.
And sir, regarding I have read in somewhere that there is some emissions from the battery also. Battery that.
Yeah, emission, not emission like CO2 emission from battery. When you try to reuse the battery, when you try to recycle the battery, there are emissions involved in that. But other than that, when you produce the vehicle, there are emissions, right? There are factories who have produced the vehicle. So yes, one vehicle we have to calculate. We are only thinking about when we drive the vehicle, what is the emission contribution to this? But that is also equally, I mean, for both electric as well as IC vehicles are same, but only the location where it is polluted is different. For IC vehicle, it is polluted there itself. For an electric vehicle, it is polluted somewhere else. But other than that, the vehicle body, when you produce vehicle body, how much emission is made from that factory? When you produce battery, how much emission is made? When you produce a motor, when you produce power converters, all are separate calculations. There are many papers available in the literature. You can check. Finally, they will confuse to write a conclusion saying that which one produce more or which one produce less. Almost are equal. Unless otherwise, you produce electricity through solar or wind 100%, and if you use electric vehicle, yes. then it is less pollution emission compared to the conventional.
Sir, and regarding the economic expenditure, means how economic will be electric vehicle as compared to conventional IC engine?
Yeah, so you can calculate the payback period. For example, initially you are spending 17 lakhs
Okay.
for a Tata Nexon, and initially you spend about 7 lakhs for the normal vehicle. 10 lakhs rupees more you spend. Okay. You also now calculate what is the total kilometer you drive. Say, for example, 1 lakh kilometer or 2 lakh kilometer. You can calculate. If there is no break-even point, it's fine. You will just go with IC vehicle itself.
Okay, sir. Thank you, sir.
So it depends how much you use.
Okay.
And about the unit cost, and your fuel cost is also rising, and other concern. That simple calculation will tell.
And sir, do current battery technology will support the electric vehicle to move uphill with loaded? We have seen, sir, goods truck, the loaded trucks. That much power will be generated with the current electric vehicle technology.
Yes. That there are electric trucks.
Okay.
The project what we work with BHL is about a 12-ton bus design.
Okay.
It costs you about 200 kilowatt motor size. So there is no any problem with the sizing of your motor. You need to have that much size battery. That's it.
Okay. Thank you, sir.
So, question from audience side. So they are asking what is the software you are using for this presentation?
What is the software?
Yeah, they are asking. The presentation was nice, so they want to know the software you are using.
Okay, you want to know the software? 1 minute.
Yes, sir.
I will show you what
Okay.
I have. Okay. I have a huge lecture studio in my home that I'll show you. Can I close the presentation then? So that you could see.
Yes, sir. Yes, sir. Yes, sir. Sure.
Okay. Whether my video is on?
Yes, sir. You're visible.
Okay. I'll switch to another camera.
Yeah. Okay.
Okay. So I don't know how much it is visible. So this is the this Wacom touch note. I don't know whether you could see that. This is the Wacom.
Yes, sir. Visible.
Yeah,
Sir.
this is the Wacom. So where I will write. So this is here where I will write, and what you could see. This is a 13-inch Wacom pen tab, display pen tab, that is connected to the processor. Okay, and then I am using just OneNote. If you could see, I am using OneNote. OneNote software, most of you may be knowing it, right?
Yes,
It's
sir. Yes, sir.
Microsoft Windows OneNote, but there are other software also. What you are supposed to do, you have to have this OneNote connected to the device, and you can consider this as a separate monitor. Like extend the screen in Windows, the separate monitor. Throw your OneNote to this screen. This is now a separate, like acts as a separate screen. And you could see other things. I could see all of you when lecture is going on, because I have two screens. Then in that screen, you do a screen sharing in your any software, Zoom or Teams or whatever. You do a screen sharing. That screen sharing, the second screen will be shared. Then what I will do in OneNote, you can bring these are all my slides. If without this, I generally used to have these slides. These are all my electric vehicle lecture note slides. This slide, but I cannot annotate. But now in this, I can have the, I can bring PDF, I can bring PPT, I can bring whatever I want, and then I can annotate in that. That will be displayed. I can bring some graphs. I can do, I can change the graphs. So all these things I can do with this. So we need to take
Thank you, sir, for
regular
showing
lectures
this.
in like this only for our students.
So thank you, sir. That was a nice presentation, and it was very informative too. So hopefully our audience got more information on what they want, and then finally showed you a studio. That was a nice one. So hopefully some of staffs are there in audience. They will use to learn it for the digital learning in future.
Yeah,
Thank you, sir.
definitely. Thank you very much. Thank you very much for your question and the opportunity. If any more detail, if you want about this course, because I'm floating a separate course, elective course on electric vehicle to our BTech and MTech students. So if anything you want to know related to the course or things like that, you are welcome. You can mail me, and we do fabricated this electric vehicle and all. Yeah, maybe this lecture is very time limited. So.
Sir, hello, sir. Subhashish here. Sir, can you
Yes.
please share your email ID so that I can write up? I am a bit interested in working on electric vehicles.
Yeah, please. I can. Yeah, I can give you my Gmail ID. Okay.
Yes, sir.
It is sankariitb@gmail.com.
Shankar
IITB.
IITP
Maybe I can.
Gmail.
I can write down and you can.
Yes, sir. Please.
Yeah, I'll share. I do here. Is it the screen shared now?
Yes, sir.
Yes, sir.
Yeah. So the email ID is this. Or a small letter. Okay. This is the email ID. And you can also visit my laboratory webpage, csrn.nitt.
Sir, we are not getting.
Not sharing?
No, sir.
The screen is shared, but it is power calculation.
Oh, that is, I think I forgot to share actual I language. So this is I have to share a window. That is, yes, sorry. Now it's okay?
Yes, sir. And now it is visible.
Yes, sir.
Yeah. So this is the website. This is the email ID. This is my lab web page, where you could see some of the electric vehicle fabricated in our lab. All these details are available. You can just check with this website. My lecture videos, if somebody interested to know something on controls, you can also check. I have lecture videos on control systems, state space, and other things. You can check. Is that fine? Yeah. You can mail me anything if you want to know about electric vehicle, books, any material. If you need, you just let me know. You can just mail me. I'll give you the links and materials I can share.
Very thank you, sir. Kind of you.
Okay, okay. Thank you very much. Thank you very much for your patience and the opportunity. We'll meet you in some other session. Okay?
Sure, sir. Thank you.
Thank you. Thank you. Goodbye. Take care.
So thank you, sir.
Yeah. Thank you. Yeah, I'll be leaving the meeting. Thank you.
Yeah, okay, sir.